What's up, people? Hello. Welcome to the session. My name is Anoop. I am a master teacher of physics here with Vedantu. A very warm welcome to all of you guys, people. How are you guys doing? How's it been? It's been a really long time since I've last come live. So, what has life been like for you guys? All awesome. Hi. Mafia Ji, what's up? How you doing? Unfortunately, there are very few students over here. We'll just wait for a couple of seconds for your friends also to join. So, in the meantime, bye. How was your day so far? What is new in life? How's your preparations going? All awesome? Yes. Life कैसी चल रही है? All good? Hello. Welcome, people. All awesome? Hi. All right. One sec, guys. I am not able to see your chats. Let me just refresh it once. Okay. All right. Hi, Ayushi. What's up? Hi, chat. What's up? Welcome, people. I hope all of you guys are doing good because today we're going to be doing subjective case study based question to help you prepare for your term 2 examinations from the chapter magnetic effects of electric current. So this is the first part of this. We have already done the same series for electricity. We're done with electricity. We did 3 sessions of electricity. Today we're going to be starting off with magnetic effects of electric current, and we'll be doing 3 sessions later on. I mean, this is the first one. We'll also be doing others parallelly, in the sense, in the series it'll keep on going. So anyways, how was your day so far? Hi, Inspired Zero. Sorry. Yes, it's Inspired Zero. Hi, Ayushi. What's up? Hi, Pari. How you doing? Like Papa ki Pari. Alright. I'm not even seeing chats for some reason. Awesome. Yeah, like there is an exam when I'm really unsure it is. I haven't been to my college in a really long time. Hi Niveda, what's up? How you doing? Welcome guys. Welcome. I hope all of you guys are doing good. And your preparations are going full-fledged. The whole session of today is going to be happening on Mentimeter. So all those who are asking, sir, Menti will be there or not? Absolutely yes, we'll have the Menti. So what I've done is I've put 3 questions of case study based questions. So 3 separate case study based questions, and each case study based question would have its own Menti. Alright, so that means that we'll have 3 different winners. So you, each and every one of you guys, have an opportunity right now to become a winner. And all these names I'll be posting up on my Instagram as well. If you guys want to follow me on Instagram, it's Anoop_Vedantu. Yes, because why not? Yes, very creative name, right? Creativity ki had. So it's Anoop_Vedantu. That's my Instagram handle. If you guys want to follow me over there, you can do that as well. Anyways, without wasting much more time, people, let's get on to the first case study based question. Without wasting much more time, I want all of you guys to join the Mentimeter as well. Hi Niveda, hi Vandana. Welcome. Thank you. All right then, so people, are you guys ready? Shall we start? Shall we all begin the Mentimeter for today's session? Yes. So here is the code for today, people. So there are 3, like I told you, 3 case study based questions, and each question has a different Menti code. So make sure that you guys are joining each of them. All right. It's not that you just join the first one and then leave the rest. Each of these 3 case study questions are super duper important, and there's a very high probability that these questions might appear in your board exams also. So it's better to be prepared than to feel sorry about it later. So the code for today, the first Mentimeter is this. It's 50812038. You guys know the drill. Go to www.menti.com, menti.com, and enter the code 50812038. And once you're in, you can take the time to read the first case study question as well. Until then, I'll just wait for your friends also to join. Whoever's joining in right now, please join the Mentimeter as well. Hi RNG, what's up? Hello, how you doing, buddy? Hello Vandana, what's up? What is up? All good? Alright, I'm not able to see your chats for some reason, guys. I have to keep refreshing it for some reason. I don't know what is happening today. Lots of bugs. Alright, thank you. Alright, so I guess that's pretty much it. Alright, so I'm guessing that pretty much all of you guys are here. So I'm going to go ahead and read the question, people. This is the first case study based question. And like I told you, in a case study based question, what happens is that you'll be given a paragraph. Something like that looks like this. A very small paragraph that looks like this. And then based on this paragraph, you'll be asked about 3 to 4 sub questions, or even 5 sub questions. And each of them would carry its own set of marks. You have to answer those questions to the fullest of your knowledge by understanding this passage that is given to you. So it's like an unseen passage in English that you get. No? So here is the question, guys. A magnetic field is described by drawing the magnetic field lines. When a small north magnetic pole is placed in a magnetic field created by a magnet, it will experience a force. And if the north pole is free, it will move under the influence of the magnetic field. The path traced by a north magnetic pole free to move under the influence of magnetic field is called as the magnetic field lines. So they are basically defining what magnetic field lines are. Since the direction of magnetic field lines is in the direction of force on the north pole, so the magnetic field lines always begin from the north pole of the magnet and end in the south pole of the magnet. And inside the magnet, however, the direction of the magnetic field lines are from south to north pole of the magnet. The question is not done yet. Thus, the magnetic field lines are closed curves. When a small compass is moved along the magnetic field lines, the compass needle always sets itself along the line tangential to it. So a line drawn from the south pole of the compass needle to its north pole indicates the direction of the magnetic field at that point. Wow, bete, wow. Such a small question, it's like a small paragraph, like nanna munna paragraph this is. I'm going to give you guys 2 seconds time. I'm going to give you guys 10 seconds time. In fact, please read this paragraph, take your own time. It's a very small question. This is the first part of the paragraph. You can read it and then I will go ahead and start with the first question. It's a very small one. So, we'll talk about that, Shashiraj. Don't worry, buddy. So, हमने अभिषेक सर को बोला था 11th पढ़ाने को. Yeah, yes, Vandana, I did. I did. Alright, so I'll go ahead, people. I'm going to go ahead and start with the very first question based on this case study. So basically, if you talk about the gist of this paragraph, they are talking about the magnetic field lines and how a magnet, works or reacts to that of a magnetic field lines, and what is the magnetic, force around the magnet is what they're talking about. So the first question based on the same people, here we go. The first question is on your screens right now. Let's go. Okay, wait, what? One sec, people, one sec. Let's just wait. Why is no one joining the Mentimeter? People, quickly join the Mentimeter. Quickly. What is this? I thought everyone's already here. The code is people 50812031. What is the point of having 4 people? Like, everyone's a winner then. There's no loser in this. What is this? Quickly join the Mentimeter. It's 50812038. Alright, quickly join the Mentimeter. What's the point of having 4 people? Join the Mentimeter quickly. Otherwise, we'll do it on the platform on this thing itself. We'll do it instead of doing it as a quiz, we'll just do it on the on the screen. What is it called as? The PDF itself. Alright. Vandanaji, I'll tell you that. Babu, I don't think so. I mean, you will have case study based questions, but I don't know if it will be this easy for you guys. It might be a little bit more, it might be a little bit more harder than what is it for CBSE. But yeah, ICC students, obviously you'll have case study based questions. God knows what type of questions they are. I would say please take a look at the past year question papers and, get a good grip of what are the possible, questions. But the one thing about ICC is that they follow proper pattern. It's not like it's not like it's not haphazard. It's always a proper pattern. So figure out what are the kind of questions that is asked from a certain chapter and focus on those chapters in particular so that you get a good grip of it, of the concepts in particular, so that you'll be able to easily answer it. All right, so that's my advice to you. All right, okay, yes, Soniji, I'm waiting. Quickly. Why is taking you so long, people? Huh? Are you all using Geo internet? I know, bad burn, but still I'm gonna ask it anyways. Are you all using Geo internet? Yes? Yeah. Thank you, Babu. I know, obviously it does. ICC rocks because I studied in ICC, so yes. Whatever I did, it always rocks. So yeah, I'm gonna agree with you. Quickly join the Menti. The code is 50812038. Once you guys are all in, I will start with the quizzes. Alright, Airtel 4G. Alright, 4G is gone, 5G is come. Just buy an iPhone, sell one of your kidneys. Why do you need a kidney? Why do you need 2 kidneys? Sell one kidney, buy an iPhone, start using 5G. Advice of the century, that is. Alright, people, so I'm going to start the quiz now. I'm trusting that you guys will join as we go ahead. So the first question for today, people, the first case study based question based on the paragraph that you just saw right now. So since you guys have just joined in right now, I'll just show you the paragraph also. This is the case question. So the question is, a magnetic field is described by drawing the magnetic field lines. When a small north magnetic pole is placed in a magnetic field created by a magnet, it will experience a force. And if the north pole is free, then it will move under the influence of magnetic field. The path traced by a north magnetic pole free to move under the influence of a magnetic field is called as a magnetic field lines. Since the direction of the magnetic field line is in the direction of force on the north pole, so the magnetic field lines always begin from the north pole of a magnet and end in the south pole of the magnet. Inside the magnet, however, the direction of the magnetic field lines are going from south to north. Moving ahead, thus the magnetic field lines are closed curves. When a small compass is moved along the magnetic field line, the needle of the compass sets itself along the line tangential to it. So a line drawn from the south pole of the compass needle to its north pole indicates the direction of the magnetic field lines. My God, I don't know why the paragraph is so very long, but the questions are actually pretty simple. All right, don't panic. The question is actually pretty simple. So here is the first question, people. I hope you guys are in. The first question is this. If you're just joining in right now, please join the Mentimeter. The code is highlighted 50812038. The magnetic field lines intersect at right angles to each other, intersect at angles of 45 degrees to each other, do not cross one another at all, or cross at an angle of 60 degrees to one another. What is this? What is the answer for this question? The magnetic field lines intersect at right angles to one another, intersect at 45 degrees to one another, do not cross each other at all, or cross at an angle of 60 degrees to one another. Very simple question. Fabulous start. Fabulous start. That's what I'm talking about, people. Absolutely. Please don't ever forget this. Magnetic field lines do not intersect each other. If I talk about a certain magnet, for example, I have a single magnet, the magnetic field lines of that magnet will not intersect with each other at all. But please understand that it's not that the magnetic field lines do not intersect at all. For example, if I have another magnet, the magnetic field lines of this magnet and the magnetic field lines of this magnet will intersect. That is what is causing attraction or repulsion. So that would happen, but for a certain magnet, for one particular magnet, the magnetic field lines will not intersect each other at all. And hence, the answer is going to be option number C. 77%. That is a good start, people. I hope that you guys are clear with it. Please don't ever forget this. Magnetic field lines in a magnet do not intersect each other. Nonetheless, Vandana, then we have God knows what, exclamation point, followed by Sony, followed by Aishi. Both of them are the fastest. Sanpreet, Dylan. Is that your actual name though? Like AP Dylan. I'm a big fan of AP Dylan, by the way. I don't know. I started listening to his songs very recently and I loved it. Brown Monday and what is that called as Excuses. Good one. I like it. Then we have Zlatan, the line himself. LOL, Nevada, Ashley, and Carl Gustav. This sounds like some, like some full-on Don wala name. Carl Gustavo. Like some Mexican Don, it sounds like. Alright, second question based on the same case study, guys. Based on the same case study. If you're just joining in right now, please join the Mentimeter as well. Don't just sit there. It's 50812038. Go to www.menti.com and enter the code 50812038. Alright, so I'm going to go ahead and go ahead with the second question, people. I hope you guys are ready for this one. Here is your second question on your screen right now. Let's go. A strong bar magnet is placed vertically above a horizontal wooden board. The magnetic field lines magnetic lines of force will be only in horizontal plane around the magnet, only in vertical plane around the magnet, in the horizontal as well as vertical plane, or in all planes around the magnet. Think about it, people. If I have a wooden plank and I've placed a magnet above it, right? Will the magnetic field of this magnet act only horizontally, only vertically, both horizontally, vertically, or in all the planes of that particular magnet is the question. Let's see how many. Confusion. So many confusions, and only 4 people got the right answer for this question. That is actually pretty sad, people. That is SSPS wala sad. Shame, puppy shame wala sad. It's okay, I mean, it happens, but let me ask you this question, people. If I have a magnet, let's say I have a magnet, right? Now, do you think the magnet will attract a nail only if it is above it? Only if it is above the magnet? Or would it attract the nail only if it is on the same, or on the wooden plank itself, on a horizontal plane? No, the entire magnet has a magnetic field around it. It's a three-dimensional magnetic field. It's not, even though in picture what we see is two-dimensional, it's not actually two-dimensional, it's three-dimensional. There's a magnetic field around the entire thing, which means that the magnetic field is there in all of the planes, not only horizontal or not only is it vertical. It's throughout the entire magnet. All right, I hope it's clear, people. So the answer for this question is option number 4, all right, or option number D in this case. It's in all the planes. Don't get that confused. Even though in pictures and all you see is, all you see is the 2D figure. It's not exactly 2D. It's actually 3D. It's actually around all of the magnet. All right. An easy way to understand is no matter where I keep the iron nail, it'll still get attracted. It doesn't matter that if it's above the magnet or it's only on the wooden plank. It'll still get attracted. Right. Anyways, Ayushi, Sunpreet, Dylan, and Lol got it right. Wow. Lol ji, congratulations. Followed by Vandana. Okay, Bakra is here. Welcome, Akraji. How are you doing? Then you have Niveda, Guhi, and Teresha. I believe there's a slight change in the leaderboards, though. That's really good, people. It's a good sign that you guys are putting in your efforts. So here is the third question for the same case study, about the magnetic field lines and the magnetic force. Here it is, people. Please pay attention. Try to do this. The code once again is 50812038. So here's what is given to you. The magnetic field lines can be used to determine the magnetic field lines. Imagine if I have a conductor and there's a magnetic field created around it. The magnetic field lines can be used to determine the shape of the magnetic field, only the direction of the magnetic field, only the relative strength of the magnetic field, or the shape, the direction, as well as the relative strength of the magnetic field. Which of these can you figure out using the magnetic field lines or magnetic lines of force? Let's go. All right. So never read case study. So you won't intersect even for two. They will basically intersect in the sense. That's what I meant. Intersect in the sense, yeah, they will collide. Yeah. All right. They will coincide or collide with each other. Yes, that's what I meant by intersect. All right. Anyways, 13 of you guys got the right answer. Congratulations, people. Fantastic job. Absolutely super amazing. Yes, it's definitely correct. Two people, they are like the 2% of this world. That 7% and 7%, 87% of the class got the right answer. Absolutely correct. It is the shape. The magnetic field lines can give you the shape of the magnetic field. It can tell you the direction of the magnetic field, and it can also help you to find out the strength of the magnetic field. If the magnetic field lines are more, that means the strength of the magnetic field line, magnetic force around that region is much more higher. So well done, people. Good thinking. Fourth question. Now, here's a leaderboard, by the way, before the fourth question. I believe all of you guys would have given the right answer for this. Unfortunately, Bakra and hashtag G or whatever got the wrong answer. We have Ayushi still on the top. Well done, Ayushi ji. Second is Sunpreet, Dylan. Then we have Lol. Sony was the fastest to answer for the last question. Vandana, Niveda, Ananya, Govi, and the rest is exclamation point and Bakra. Congratulations, people. Moving on to the fourth question for the same case study based question. We have 5 questions in total for this one, and then we have another 2 mentee links as well. So here's the fourth question for the day, people. So here we go. The question is, what is the question? Let's take a look at it. The magnetic field lines due to a bar magnet are correctly shown in which of the figures? A, B, C, or D? Bacha question. Think about it. The magnetic field lines around a bar magnet currently shown by which of these? Like such a simple nanna manna question this is. If anyone gets this wrong, no. Such a simple question. What do the magnetic field lines look like around a bar magnet is a question. Such a simple question. It's okay, Ananya. I understand. I really understand that. It's okay. Don't worry. You get that confidence with time. So stay calm. All right. Was it all the best, Udeji? All the best, buddy. All the best. Do well. Make us proud. 11 of you guys, again, a fantastic job, people. Fantastic job. That's what I'm talking about, because that is what is absolutely the correct answer. It's going to be 79% again. Fantastic job. Yes, it is basically the magnetic field lines outside the magnet are going from north to south pole, but inside the magnet they're going from south to north. So please don't ever forget that, people. Absolutely correct. The right answer is option number D. No doubt, that is definitely the correct answer. Well done, guys. Fantastic job. And if you talk about solenoid also, it's very similar to that. My god, what is this? Like, the three people who managed to get the right answer for the previous question unfortunately got the wrong one in this one. Like how that question was actually, what to say, pretty confusing, and all of you guys, that is Ayushi, Dylan and Lol, got it right. And now to what is this people? Oh my god. Anyway, Sony was the first to answer, followed by Ayushi now, followed by Dylan, followed by Vandana, Niveda, Lol, Ananya, Gui, Uday, 10 Pro Badge, welcome buddy, and then Ankita as well. Fantastic guys, fantastic. That was completely opposite of what I saw before. Okay, so last and the final question, people. The last and the final question for the first quiz time, because we have two other case study based questions, two different links, so two different leaders. So here is your final question for the first one. Take a look at this one. The question is, which of the following is not true about the magnetic field lines? Which of those is not true about the magnetic field lines? Options are: magnetic field lines are the closed and continuous curves. No two field lines can cross each other. The crowdness of the magnetic field lines represents the strength of the magnetic field. The direction of the magnetic field lines is from north to south pole inside the bar magnet. Think, people. Use that amazing brain of yours. Try to do ASMR now. When did I ever do ASMR? What is ASMR? I don't even know what it is. So confusing CND. It's okay. Happens. So why does a moving charge only produce magnetic effect? See, the thing is that, like I told you, when you can understand that a magnet is nothing but, if you talk about a magnet, what makes a magnet is the arrangement of the atoms. All right. So in a magnet, the atoms and molecules are properly arranged. So when current is flowing in a particular direction, all the electrons and everything are flowing in a particular direction. So the arrangement of atoms and molecules is what you're trying to achieve there. And because of those arrangement of atoms and molecules, because all the electrons are now moving in the same direction, although they're not moving in a straight line, they're moving in the same direction. That is what is creating the magnetic field. So please understand that this is the basic concept. So if I talk about a magnet, right, this is how I understand it. Right? This is how I understand it. When I was a kid, this is how I understood it. So if you take a bar magnet, for example, what makes a bar magnet magnetic is the arrangement of the atoms and molecules. You can see that this bar magnet contains atoms and molecules that looks like tiny little bar magnets inside of it, and each of them has a north and a south pole. The arrangement of the atoms and molecules is what is making that magnet magnetic. Alright, that is what is creating that magnetic force. So here also, because all the electrons are moving in the same direction, or the charges are moving in the same direction over here, that is what is creating that magnetic field. So that would be one way to understand it, right? Anyways, 10 of you guys got the right answer for this question. Fantastic job, people. Absolutely correct, because all the other three options are absolutely correct. Magnetic field lines are closed continuous curves. They are, they do not intersect with each other. And yes, the more the number of magnetic field lines in a certain region, the stronger the magnetic force in that region. And last but not the least, the one thing that is wrong is that the direction of the magnetic field inside the magnet is going from south to north, not the other way around. Inside the magnet is going from south to north. Nonetheless, people, here is your final leaderboard for the first quiz time. We have Sony J, congratulations. Sorry, congratulations. I think, yes, Sony is the winner for today. Congratulations, fantastic job done. Second is Dylan G, followed by Ayushi, followed by Niveda, followed by Gui, followed by Ananya, followed by Vandana, then it's Ankita, Uday, and Lol G. What happened? You are in the third position, third to last. Ki ho gaya? It's okay. Well done. Fantastic job again. Not to worry, people. We have another, Mentimeter right now. So I'm going to go to the case study number 2, people. I'm going to go to the second case study based question now. The code now is 7276714. Alright, so please join this Mentimeter right now. You have to just leave that remember, go back and enter the next code. It's 7276714. Alright, let's go. You can say that, Shashira. You can say that. In a way, you can say that. Ukraine war is already started. Okay, I didn't know about that. I mean, I know that they declared a war, but I didn't know that it already started, though. Is it? All right. So if we somehow join two bar magnets together, like they're, from their like poles, like we glue them or something, so wouldn't that make it a monopole? Okay, if you were to, you could see, it wouldn't make it a monopole per se. You can say that, I mean, it's not exactly monopole, right? Even then, like the other side is still South Pole. If you talk about two North Pole being joined together, the other side is still South Pole. So how does it make it a monopole? Monopole is when you have only one single pole, and that is not possible. Theoretically, yes, it is possible, but practically it is not. All right. No matter how small a magnet is, no matter how many times you break that magnet, you will still. I don't know if you have noticed this before. Like for example, if I break a magnet. This is a very good question. Just think about it, guys. If you take a magnet and break it in half, and if you try to join them together, do you think it will join? Have you guys ever tried this before when you were kids? Have you guys ever tried this? If you break a magnet in half and then try to join them together, do you think it joins? Have you guys ever tried it before? Like, will it join? No, it will not. It will not. The broken sides will not join. If you try to, join the broken sides, it will not join. Because what is happening is the minute you break it, the other side becomes, for example, if one side is north, the other side immediately becomes south pole. It automatically becomes the south pole. All right. So it doesn't work like that. All right. Even if you glue them, also it's pretty much the same thing. All right. Exactly. No, so it's not like it's monopole, right? It's not monopole means everything is north pole or everything is south pole. That does not happen. No, it's still there is north and south pole, right? Okay. Anyways, so people, I'm going to go ahead and read this case study question. Case number 2. Please join the Mentimeter in the meantime. It's 7276714. Beautiful number. So here's the question. Andre Mary Ampere suggested that a magnet must exert an equal and opposite force on a current carrying conductor, which was experimentally found out to be true. But we know that current is due to charges in motion. Thus, it is clear that the charge moving in a magnetic field experiences a force, except when it is moving in the direction parallel to it. If the direction of motion is perpendicular to the direction of magnetic field, then the magnitude of force experienced depends on the charge, the velocity of this charge, the strength of the magnetic field, the sign of the angle between the velocity, the charge as well, the velocity as well as the magnetic field, and they're also talking about the direction of the magnetic force, and the direction of the magnetic force is given by Fleming's left hand rule. So basically, people, they are talking about the formula F is equal to BIL wala formula, the formula that you have in this chapter, the only formula that you have in this chapter. So they're talking about that formula, and they're also talking about Fleming's left hand rule. All right. So based on this, people, again, I'm going to ask you about 3 to 4 sub questions. So get ready for that. So I'm going to wait for some time. So they've actually shown you the picture of Fleming's left hand rule as well. For all those who are confused, Fleming's left hand rule states that if you take your left hand and extend your middle finger and your index finger such a way that they're all perpendicular to each other, then what happens is that the thumb shows the direction of force on the current carrying conductor, in which direction the force is acting or the motion of that conductor is shown by your thumb. The index finger shows the direction of the magnetic field, and the middle finger shows the direction of the current. All right. So using this Fleming's left hand rule, you can find out the direction of the force acting on a current carrying conductor. That is, when a current carrying conductor is placed in a magnetic field, that current carrying conductor will experience a force, and that direction is what is represented by Fleming's left hand rule. So with that understanding, people, I'm going to go ahead and start with the very first quiz question. I'm going to wait for a couple of seconds so that you guys can also join. I hope everyone is here. If you're just joining in, people, the code is 7276714. This is a brand new Mentimeter, so you can, with full confidence, with full josh, you can try to win this one. All right. I'm going to go ahead, people. I'm going to go ahead and start with the quiz. Here is your first question for the second case study based question. I hope you guys are mentally prepared for this one. Here's one. If an electron is traveling horizontally towards east, a magnetic field is vertically downward direction exerts a force on the electron along the east direction, west direction, north, or is it going to be south? Think about it, guys. If an electron is traveling horizontally towards east, the magnetic field is vertically downward direction exerts a force on electron along which direction? East, west, north, or south? You have to use Fleming's left hand rule over here, but I'm pretty sure that a lot of you guys would end up making mistakes over here. But this kind of questions is a short question, guys. There's a very high probability that these kind of questions might be asked, and I was so right. 3 of you guys got the right answer for this. How do you guys feel? Yeah, please give me a small interview. How do you guys feel at this point of time? How proud are you guys feeling at this point of time? Yes, please. Would you guys like to give a small interview? Yes, please. Such great personalities. 19% of the class. Wow, wait, wow. Is it okay? Congrats. I like the meme, no, like the meme. Alright, so it is. How do you do this, people? How do you do this? Let me explain this. It's very simple, actually. Okay, now tell me, guys. Tell me one simple thing. If if electron is moving towards the east direction, what is the direction of current? This is the biggest mistake that you guys did. If electron is moving towards east, what is the direction of current? What is the direction of current? Think about it. If electron is moving towards east, then what is the direction of the current? Exactly. West is the direction of current, because current is always opposite to the flow of electrons. Conventional current is always opposite to the flow of electrons. So if electrons are going towards east direction, then your current is actually going in the west direction, which is shown by your middle finger. Now, middle finger is showing in the left-west direction. The magnetic field is downwards. What I would say to avoid confusion is start with the magnetic field. It's much more easier than. Magnetic field is pointing downwards. Current is going in west direction. So what is the force experienced by the conductor? It is towards me, isn't it? It is towards me, which means that it is in south direction, or you can say it's out of the page. Or it's south direction. This is north, this is south. If this is east, this is west, this is north, and this is south. So towards me, that means that the right answer is south. Got it? So this is the biggest. See, this is what you need to pay attention on. If they mention the word as electrons, if they mention the word as electron, then please don't take that as the direction of current. This is the biggest fault that a lot of you guys. That's why I put this question in particular, so that you guys do not make that mistake in your examinations. At least you can make mistakes over here, but please don't do that in your finals, right? Anyways, Uday, Johanna, followed by Samyukta were the only three people who get it right. Everyone else, Anda, Puja. 0. Super awesome. Account closed. Alright, second question. We still have a lot of questions to go through, so don't worry about it. Chill. Second question, people. Second question. Here we go. I hope you guys are ready for this one. The question is, again, pay attention, guys. Pay attention. Use your okay. If a charged particle is moving along the magnetic field lines, the magnetic force on the particle is, if a charged particle is moving along the magnetic field line, the magnetic force on the particle is along its velocity, opposite to its velocity, perpendicular to its velocity, or zero. Think carefully, guys. Such an easy question. You would easily get the answer if you just think about it. If you use that formula, no, aram se you can do this question. So think very carefully. All right. I know, what to do. Anyways, so here we go, people. The answer to this question is, oh my god. Please kill me now. Just kill me now. 4 people. Last time 3, this time 4. What improvement? What an improvement. I'm so lucky to be doing this 24%. I'm telling you, no. Alright. So people, how do you do this again? See, the thing is very simple. Alright, just think about it. See, I'll just go to this question. Alright, let me just skip to that question first, so that it'll make some sense to you people. So here is a question, guys. Your charged particle and the magnetic field lines are both in the same direction. Magnetic field line is also the same direction. The charged particle is also moving in the same direction. Let's say it's an electron moving in the same direction. Alright. Same direction, all right? Or a charged particle, let's say Q is moving in the same direction, all right? Q is flowing in the same direction, magnetic field is also in the same direction. Now, if you use a formula, that is to find out the magnitude of Lorentz force, the formula is what? F is equal to BIL sine theta. Now, tell me, guys, what is the angle formed between the magnetic field and the current here? What is the angle formed between the magnetic field and current here? What is the angle formed? What is it? Think. What is it? What is it, by geniuses? Exactly 0. What is the value of sine 0, people? What is the value of sine 0? If you substitute that in the equation, F is equal to BIL sine 0. What is sine 0? Sine 0 again is under, exactly. So the whole term becomes 0. So remember this, people, if you want maximum force on a current carrying conductor, then the current and magnetic field will be perpendicular to each other. Alright, if you want maximum force. If you don't want any force at all, all right, if you don't want any force at all, then the current and magnetic field would be in the same direction parallel to each other. In that case, the amount of force, the amount of Lorentz force acting on it, it's called as Lorentz force, that would be 0. All right, again guys, amazing questions, but I hope that you guys are able to understand what your mistakes are. The same mistake, the silly mistake that you guys are making is what is causing all this. So please correct them in your examinations, before your exams at least. All right, anyways, Ankita, hi, now what's up? The top, followed by Shan, then it's Love Site. And it's Uday, followed by Joanne, followed by Ruhi, followed by Samyukta, Clippy, Johnny, and Achintya. Unfortunately, haven't opened up the account yet. Johnny, yes, Papa, come on, you can do it. All right, okay, here's another one. The third question, people, the third question. I hope you guys are ready for this one. If you're just joining in right now, please join the quiz, people. It's 7276714. That is a code. Please join in and take part in the quiz. The third question for the day, people. Third question for the second case study. A magnetic field line exerts no force on a stationary electric charge, a magnet, an electric charge moving perpendicular to its direction, an unmagnetized bar magnet or iron bar. A magnetic field would exert no force on which of these? No force whatsoever. All right. A stationary electric charge, a magnet, an electric charge moving perpendicular to its direction, or an unmagnetized iron bar. Think about it. All right. Fantastic, people. Finally. Is that more than 50% at least? Okay, 40%. Not bad. Like, it's not that bad. Like from 3 to 4 to 8, not bad. Like double of what we saw before. So I'm, I don't want to kill myself anymore. So that's good. Absolutely correct, people. The right answer is a stationary charge. Absolutely, because if it's a stationary charge, that means current is not flowing through it. And if current is not flowing through it, obviously there'll be no force. There'll be no Lorentz force acting on that current carrying conductor at all. But yes, if you talk about a magnet, if you have a magnetic field, if there's a magnet, obviously the magnet would attract or would repel the magnet. There will be force of attraction or repulsion. It will exert a force if a charged particle is moving perpendicular. In fact, the force would be maximum. And yes, if it's an unmagnetized iron bar also, iron is a magnetic material, so it'll obviously get attracted if it's placed within a magnetic field. So the only thing that makes sense is option number A. Congrats, guys. Congratulations, smart people. So here is your leaderboards after such horrible questions so far. Horrible 2 questions. Some glimmer, from some glimmer of hope we have. Shan followed by Ankita, then it's Uday, Niveda followed by Johnny, Ayushi, Preksha, Ravi Stewart followed by Aradhya, and then Shalvi as well. Fantastic, guys. Fantastic job. The last and the final question. This is for the second quiz time or second case study based question. We have another case study based question also, so don't leave it. We have another one, so do not miss that one out. That is also super duper important. The questions are super amazing. So last question for the second case study based question, people. If you're just joining in right now, you can join the quiz as well. It's 7276714. In fact, I would say to wait for the next one. An electron beam enters a magnetic field at right angle to it as shown in the figure. The direction of force acting on the electron beam will be what? To the left, to the right, into the page, or out of the page. An electron beam enters a magnetic field at right angle to it as shown in the figure. The direction of force on the electron beam will be what? To the left, to the right, into the page, or out of the page. Come on, guys. Come on. Think about it. Is it Shishiraj? It's okay, it happens. You're standing out. Getting it? You're standing out of the crowd. Absolutely, Snowflake Ji, why not? Please do. Absolutely, you should. So why Vedantu prefers CBSE? Because most students, exactly. That is the reason for that. Most students, see, I personally studied in ICC school. Honestly speaking, I did not know that CBSE existed when I was in 10th standard. My world knowledge was so awesome that I did not know that CBSE existed. I thought ICC is the only thing that ICC and State Board are the only 2 boards that you have. I mean, that's how amazing my knowledge was. My world knowledge was when I was in 10th standard. So, happens. It's okay. You will also get your chance. You will also get your revenge. Don't worry. When you go to 11th and 12th, ICC students will find it a lot more easier at that time. So don't worry. Relax. You'll also get your time. Anyways, the answer to this question, people, absolutely fantastic. You have corrected your mistake. And for that, people, hats off. because you've corrected your mistakes, you'll learn from your mistakes. That is what I was talking about. Absolutely, guys. So if electrons are if the electron beam is moving downwards, then the current would be in the upward direction. And if you look at the magnetic field is going from I don't know the question yet. One second, let me just take a look at the question. So yeah, electron beam is going in the downward direction, which means that the current is going in the upward direction. Magnetic field is going from left to right. So what is the direction of the thumb then? Thumb is facing the screen, which means that the force experienced with the conductor would be into the page. If it is basically going away from you, that's into the page. If it is coming towards you, then that is out of the page. Right? So in this case, it's into the page. So that would be the answer. Fantastic, guys. You've actually learned from your mistakes. I'm actually very proud of that. You guys, 70%. The last question was 3. Now it's 70. That is fantastic, guys. What a brilliant jump. Fantastic job. Anyways, Shan followed by Ankita followed by Uday. Niveda, it's okay. Don't worry. Don't feel bad about it. Preksha, I love you guys. I'm not able to read the rest of the names. Lavanya, I believe it's Lavanya. Then it's Samyukta, Boss, and Niveda. Shan, congratulations, buddy. Fantastic job. So amazing. You did really, really well today. Fantastic. So that is the end of the second question. Let's move on to the last and the final case study based question, guys. The last and the final case study based question. So please join this one. The code again is 1801759. All right, that's the code. Please join the Mentimeter. This is the last and the final case study question. Super important again. So please pay attention. It's more about solenoids and stuff like that. So please pay attention and give your 100% once again. The code is 1801759. Again, new set of leaders. So every one of you guys have a chance to make a name for yourself. So go ahead and do it. All right. Okay, people. Okay, so before we go to this question, guys, before we start with the quiz, I also have to tell you something very important. I know you guys already know what is coming, but I still have to say it anyways. And that is for all the new students out there, people. If you guys are looking for a region or a place to kickstart your revision, and you're still wondering what to do, where to do, what not to do, and how to, approach your examination, you're still worried about that. Let me tell you this. Don't have to worry anymore, because we are here for you guys. With the Drona batch, you're getting an opportunity. With this brand new Drona batch, you're getting an opportunity to study with the best of the best master teachers from Vedantu 9th and 10th Hindi channel. That is Abhishek sir, Harsh sir, Ankana ma'am, Amit sir, Anuva ma'am, and Amrit sir as well. The fabulous, 5 of this, all right, 5 people would be teaching you guys over there. 6. I missed out Anubhava because of the height. But anyways, 6 of these fabulous teachers will be teaching you on the Vedantu platform to help you with your revisions throughout the year, throughout your term 2 examinations. And you'll have about 30 plus live sessions over here with complete notes, with quizzes, with last minute tips and tricks to help you control that anxiety of yours. Complete revision of the entire syllabus for physics. That will be both electricity and magnetism, which means that numericals will also be done. Revision of the topic also would be done. So the complete package is what you're getting from this Drona courses, and you're getting an absolutely wonderful offer over here, guys. Again, everything that you love about Vedantu, all of it, you're getting a part of it. You get to enjoy it, and you get to understand the syllabus and prepare yourself better for your term 2 examination, because I know that all of you guys really want to do well, and this is an opportunity for you guys to make it better. I would say to make it, to help you in the right direction, to guide you in the right direction, to make it a little more better, a little more fruitful. That is the whole point of having this Drona batch. We're working day and night to kickstart this, and we're making sure that you guys are getting only the best of the best content and nothing else, right? So everything that we love about Vedantu, like the quizzes, the hotspots, the leaderboards, and you have the fastest fingers list, the stars, which a lot of you guys love about. We have the drum rolls and doles and whatnot, Gunty. We have got all sorts of animations out there. We have leaderboards. Again, you also get to chance to talk to the teacher. That is one of the best feature at Vedantu, because I know that a lot of you guys don't get to get your doubts cleared because of the fact that there's a lot of technical constriction over here. But on the platform, people, you can actually talk to the teacher and get your doubts cleared. You have an option to unmute yourself. We can actually unmute you, and you can talk to the teacher directly and get your doubts solved. Even you can even uncam yourself. You'll be literally able to do a voice chat and a webcam with your teachers, and you can actually get your doubts solved right there and then. And not only that, people, Along with the master teacher, you will also have someone called as a class teacher in the doubts panel. So if you have any doubt at any point of time, I'll just show you small statistics. If you just look at this one, no, in this particular class, right, about 88 doubts were asked. And look at that. All of those 88 doubts were solved inside the class system. And that is the kind of support that we are offering you guys for this very, very amazing, fabulous price. And yes, you can download all the notes, watch the recordings whenever and wherever you're from, doesn't matter. You want to watch the recording of a certain session, doesn't matter. Just click on replay and you can watch the entire session whenever, fast forward it, or go through the entire thing, download the notes of it by clicking get notes. So all of the things that you love about Vedantu, you're getting to experience that right now for your term 2 preparations. So let me just tell you how to enroll in the course as well. Very simple 3-step process, that's all. So what you have to do is basically, first of all, go to the description of this video. You guys are already watching it, so you have to click on the description, the drop box. If you're watching it on a phone, if you're on your laptop, then go to the description and click on this option called a CBSE Term 2 Full Syllabus. And that link, people, is all that you need. This link would directly take you to the web page where you're automatically, a coupon code of mine is already applied. That is AME Pro coupon code is already applied to this. If you go from the description of my video right now, and here again, notes and replay, the entire crash course, subject-wide test, everything that you get a part of it, and all of it until the end of your examination. That is, right now it's Feb, it's almost the end of Feb, so March, April, until your exams are done, which will be the end of April or the first week of May, you will be getting these sessions, 30 plus live sessions, for just 2,970 rupees, which is roughly about 1,500 rupees per month. And if you just think about it, for all the 6 subjects, that is a really good deal. For physics, chemistry, bio, math, English, social science, with notes, with practice questions, with PYQs, with mock test paper, that is a pretty good deal, people. For 3,000 rupees is actually a very good deal. And not only that, with this 10% discount that you're already getting if you use my coupon code AME Pro, along with that, you also have this thing also, you can actually get 15% cash back on Amazon as well. So that's about 25% cash back that you're actually getting if you enroll into the course right now. If you're using MobiKwik, the other, the payment app, that's around 10% of cash back over there as well. So think about it, and the choice is yours, but I would say do not wait and waste your time, because time is marks for you guys, not time is money. It's not time is money for you people. Time is marks. The more you put in the effort in the right direction, the better the chances are of you getting really good marks and you having that confidence that you require. Because right now I know that your confidence is at the lowest point because of your, because of your pre-boards and everything going on right now. And generally what they do is they make the pre-boards a little harder to make it so that your final exam is a lot more easier for you. But the biggest problem with that is that you end up hampering your confidence. Your self-confidence actually goes down a lot because of your pre-boards. So I would say do not wait any further, because the more you wait, the more chance you're giving for that self-doubt of yours, and you're feeding towards that. You're feeding that negative energy that you have, and that would again impact your exams one way or another. Right? So anyways, enough talking. Let's get into the questions. So here's the code, people. Once again, all those who are here, let me just check how many figures are in right now. The final code, people, will last at the final Mentimeter, so please join this one. It's 8101759. All right, that's the code. 1801759 is the code, and I'll just read out the question in the meantime. Please join the quiz. So the code, the paragraph is: an insulated copper wire wounded on a cylindrical cardboard tube such that its length is greater than the diameter is called a solenoid. Alright, so solenoid is basically a wire which is wound like a spring. When an electric current is passed through the solenoid, it produces a magnetic field around it. The magnetic field produced by a current carrying solenoid is similar to that of a magnetic field produced by a bar magnet. The field lines inside the solenoid are in the form of parallel straight lines. The strong magnetic field produced inside a current carrying solenoid can be used to magnetize a piece of magnetic material like soft iron. So if you were to place a soft iron material into it, that can also get magnetized. When placed inside the solenoid, the strength of the magnetic field produced by a current carrying solenoid is directly proportional to the number of turns of the solenoid, and it's also directly proportional to the strength of the current flowing through the solenoid. So more the current, more is the magnetic field produced. If you were to increase the number of turns, that could also increase the strength of the magnetic field. So keeping that in mind, people, I'm going to go ahead and start with the questions. So please join the quiz. If you're just in right now, you're joining in right now on YouTube, the code is 1801759. Again, a brand new Mentimeter, brand new link. So brand new leaderboards. So pay attention and give your very best. All right. So 4 questions, last 4 questions. Here's the first one on your screens. Let's go. The question is, the strength of the magnetic field inside a long current carrying straight solenoid is more at the ends than in the center, minimum in the middle, same at all points, found to increase from one end to another. What happens to the strength of the magnetic field inside the solenoid? Inside the solenoid, what is the strength of the magnetic field like? Let's go. So the revision, the marker will start with my prelims. How is it? I would say focus on your prelims. Obviously, I would say focus on your prelims. You can watch the revision. I mean, the Dhamaka replay, you can watch it later on your weekends when you get time. You can watch it. But I would say focus on your prelims. Obviously, your exams are more important. All these sessions are there to help you with your preparations. But you can never, set that more important than your exams itself. So please focus on your exams, and you can watch the recording of it whenever you want. So if you have any doubts, anything like that, you have my number also. So give me a call. We'll get it sorted. All right. Anyways, yeah, all right, sure, I'll be almost done. I'm almost done. 10 of you guys got the right answer. Congratulations, people. But yes, to clear this point, people, if you have a solenoid, we know that inside the solenoid also the magnetic field lines are present, and these magnetic field lines inside the solenoid are actually parallel to each other. They're parallel to each other, and they basically, okay, I'm showing you all the answers. It's basically parallel to each other, right? So if you talk about a solenoid, the magnetic field lines are parallel to each other. Parallel means the magnetic field lines are uniform, and it is also same. It is uniform throughout it's pretty strong, and they're very close. Because of that, they are actually pretty strong, and on top of that, they're also very, very uniform, and that's why they're all parallel to each other. Because they're parallel, we can say that it's uniform, right? So inside the solenoid, whether it's the north pole or the south pole, the magnetic field lines inside would be uniform in the case of a solenoid. All right. Second question, people. I hope it's clear. Please do pay attention to these small details. You'll get it right. Anyways, Kushagra, Sean, followed by Niveda, followed by Barefoot Contessa. Congratulations. Why are you barefoot, by the way? Then we have Rohi, Tinky, then we have Preksha, Ayushi, Harish, Delsi. Like how do you guys come up with all these names? Such creativity, such height of creativity. All right, second question, people. Second question. Here we go. The second question for the day. I hope you guys are ready for this one. The question is, what is it? The north-south polarity of an electromagnet can be found out using what? By using Fleming's left-hand rule, by using Fleming's right-hand rule, by using the clock-phase rule, or using the left-hand thumb rule. Which of these can be used to find out the polarity of an electromagnet? How do you find out which is the north pole and the south pole? That is the question. All right. How is that being a scientist is easy. Scientist, all right. Anyways, the 3 legends in one batch. Harsh, Amrit, oh yeah, exactly. The 3 musketeers. The 3 musketeers of Vedantu. 13 of you guys got the right answer. Fantastic job again, people. Fantastic job. For all those who are confused about this one, please avoid this confusion, because absolutely it's a clock phase rule. Because all the others, for example, if you talk about the Fleming's right hand rule, that is used to find out the direction of the induced current. Fleming's left hand rule is used to find out the direction of the force on a current carrying conductor. The right hand thumb rule is basically used to find out the direction of the magnetic field around a straight current carrying conductor. The only thing that is used to find out the direction of the polarity, that is in which direction which one is the north and the south pole, that is the clock phase rule. Please remember, if current is going in anti-clockwise direction, that is the north pole. If current is going in clockwise direction, that would be the south pole. Clockwise, south pole; anti-clockwise, north pole. So that's how you find out the direction of the polarity, right? Okay, third question, guys. Almost towards the end. All right, the final 2 questions we have for today. I've been shouting out for the past 52 minutes now. Kushabra, the fastest to answer, followed by Sean, followed by Barefoot Contessa, followed by Pinky, Ayushi, Niveda, Preksha, Ruhi, Harish, and Delsi. Congratulations. I had an American twist to it. Harish. All right. Third question, people. Third question. We have last 2 questions left out. That's it. So third and the second last question for today. Please pay attention. Let's go. Here we go. The question is, for a current in a long straight solenoid, north and south pole are created by the 2 ends. among the following statement, the incorrect statement is the field lines inside the solenoid are in the form of straight lines, which indicates that the magnetic field inside is same at all the points of a solenoid. The strong magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. The pattern of the magnetic field associated with the solenoid is different from the pattern of the magnetic field around the bar magnet. Such an easy question. The options are so small that I have to use a magnifying glass to see it. But I hope that you guys were able to read it at least. Nonetheless, arre bete wa, Moj kardi. Congratulations, people. 16 of you guys. That's a fantabulous job, people. Fantabulous job. 2 of you guys got the wrong answer. That's perfectly fine. 16 got the right answer. Fantastic job, people. Absolutely correct. It is that the magnetic field around a solenoid and a bar magnet is very much similar to each other, and hence the only option that makes sense is option number C, which is not true. All right. Anyways, so here's your leaderboard, people. Again, break, because all of you guys have answered the right answer. Oh, Shan Kushagra Bhavdeep sir student. Arey, what's up? The legend. Followed by Babu Prithvi 69 What? Babu Prithvi 69 ICSE. What is this? Underscore and all. Aishi, Deveda, followed by Rui, Harish, Preksha, and Delsi. Congratulations. Oh, is it? I don't know what is that. I wish, sometimes when I do all these blunders when I show the answers, I wish that if you guys ever watched this thing, what is that, Men in Black, there's this pen kind of thing that they use, they flash it and everyone forgets what had all happened for the last 5 minutes or 10 minutes. I really wish sometimes I had that thing, every time I do all these blunders of showing the answers, I wish I could just flash my camera and then all of you guys forget the answers and then we start over all again. It would be nice, but unfortunately, Men in Black is not true in real life. I wish it was. Alright, the last and the final question, people. Here's the last and the final question. A soft iron bar is enclosed by a coil of insulated copper wire as shown in the figure. When the plug of the key is closed, the phase B of the iron bar marked as... the phase B is what? Is it the North Pole, the South Pole? North Pole if current is large. South pole if the current is large. So we have given 2 poles. If you can notice that there's a soft iron core placed inside the solenoid. A is one side, B is one side. What is the polarity of B is the question. Is that the North Pole, the South Pole, North if current is large or South if current is large? Let's go guys, let's go. So chemistry, moles, physics, vectors and bioreaction. I'm sorry. I don't know why I found that funny. Anyways, 10 of you guys got the right answer. It's like a beautiful step, 10, 7, 2 and then 0. But anyways, congratulations guys, congratulations, well done. I mean, not well done, but it's okay while our result. See guys, if you look at this one, if you look at the last question right now, if you just look at the last question, if you pay attention, you see that current is actually, current looks like it is going in anti-clockwise direction. So this wire is in front, isn't it? So if it's behind, you see that there's a dotted line. So you see that if the current is behind if the wire is behind the, soft iron core, it is represented by dotted lines, as you can see over here. So this one's in front of it. So it means the current is flowing in anti-clockwise direction. So when you see from this side, current is going in anti-clockwise direction. So if current is going in anti-clockwise direction, that would be the North Pole. So this is the North Pole, then this automatically becomes the South Pole because every magnet has a North and a South Pole. So that'll be the South Pole. All right. So that's it, people. That is the answer for the last question. The answer for this one is North Pole, and that is the end of today's fantastic session. And I hope you enjoyed it, people. Please hit the like button, subscribe to the channel if you guys are new, and I'll catch you guys in the next session. All right, so here's the final leaderboard, by the way. We have, I believe, Shan is the winner again. Is it? Oh, yes, Shan. 2 out of 3. Bagged it. Congratulations. Very well done. Very well done. Super awesome. Look at him smiling. 3,935 points. Followed by Kushagra. Then it's Harish. Followed by, not able to read the name. Then it's Rui. Followed by Vandana. Followed by Bhavdeep Sir Vedantu. Followed by Babu. Followed by Aishi and Niveda. Congrats guys, congrats. That's it for today. Fantastic job, fantabulous job. All of you guys have done really, really well. I'll be posting all of this in my Instagram handle. Again, if you guys want to follow me over there, you can do that. I'll be more active on Insta from now. So that's it, people. That's all for today. Thank you for joining. And yes, the link for Drona batch is right there. For ICC students also, I'm not ignoring you people. There's a link right below the CBSE sessions for ICC students as well. The whole crash course for term 2 for ICC also. It's right there. The whole syllabus would be here. Again, it'll cover the entire syllabus. But the price of that is a little higher because there's a lot more to cover here. So that's around 8,775 rupees. But you don't have to pay the entire amount. You can actually do the EMI, go with the EMI option. That's around 2,925 rupees a month. Alright, again here also you have discounts. You'll be getting 15% discount on Amazon cashback and 10% discount on MobiKwik if you were to use any of those apps, right? So that's pretty much it, guys. That's all for today. I hope you enjoyed it. If you did, hit the like button, subscribe to the channel, and more importantly, let me know if you have any doubts. I'll try to clear it up. And all the very best of luck for your pre-boards. I really hope that every one of you guys performed really well in your pre-boards. Enjoy it, right? Enjoy it while it lasts, because this would be a last year in your schools as well. So enjoy it while it lasts. You guys are the seniors now, so enjoy. By the same time, take your exams a little seriously as well, because although marks don't matter as much, it does matter for you to get into a good college for 11th and 12th. So that sets your path. So do well and give your 100%. Whatever you do, please give your 100%. Every time you take your book, the only intention that you should have is this, that I am going to give my 100% today. Even if I study for 30 minutes, I'm going to give my 100% today. Because at the end of the day, people, quantity does not matter, quality does. So focus on quality and not quantity, because you can study for 8 hours a day and not understand anything at all, right? You can study for 8 hours a day and not understand anything whatsoever. So focus on quality, not on quantity, and pay attention to the slight mistakes that you didn't know. Like for example, when we talked about electrons, you took the direction of electrons instead of current. All these tiny mistakes, corrected right away so that you don't repeat that in your finals. And that comes with your understanding of the fundamentals. So read your NCERT, make your fundamentals clear, and you'll rock the exam. Trust me on that. All right. Is it snowflake जी? अरे awesome. सर कौन से टीचर पढ़ा आपको? I have no idea. So अभिषेक सर के बिना physics अच्छी? Oh, is it? I know, right? I know. Abhishek sir is like the child of physics. No, not child. The god of physics. The god. He's not the god. He's got the god of physics. God. Like god. He's like the god of physics. Yes. What? No. Hey, so people, hi Rachel, what's up? How are you doing? All the best, Rachel ji, all the best, do well. Sir, what is that? Automatically enrolled in that batch. Awesome, all the best, do well. Sir, Abhi sir ke, is it Ananya? That's okay. See, at the end of the day, it doesn't matter who you learn from. At the end of the day, it doesn't matter who your favorite teacher is. If you're able to understand the concepts, that's all that matters. So if you're able to understand from Abhishek sir, then why not? What are you waiting for? There's nothing wrong in it. All right. So whatever it is, at the end of the day, all the teachers are there to help you guys out. And if you guys are finding it helpful, then please go ahead by all means. All right. No hard feelings. All right. Don't worry. Anyways, guys. Oh yes, absolutely. So I'm not getting any concept of 11th standard. It's okay, Vandana. I know it's a little hard. That's what I'm trying to tell you. All of a sudden from, when you move from CBSE 10th to 11th standard, everything changes. Everything suddenly changes, right? Everything is different. Everything is a lot more harder, a lot more numericals, lot more stuff to learn, a lot more stuff to remember, a lot more formulas, a lot more derivations. So everything is like twice the things that you have right now. So it takes time for you to get accustomed to it. It takes time for you to get used to it. But eventually you will. You just need to have that patience and don't give up. Alright, don't give up hope. Because it's just the first few months, right? It's just the first few months of your, I know it's the last few for your 11th standard, but it's the first few for your 12th standard. And 12th marks is what matters more than 11th standard. I'm not saying that 11th doesn't matter at all, but in comparison, 12th standard matters more than 11th standard. So I would say that don't panic, don't feel tensed, relax, and try to understand the concepts, whatever you can grasp, whatever from wherever it is. There are lots of free content, and there are some amazing teachers on YouTube who does some super amazing work. I'm not taking out their names, but you guys know who I'm talking about. There are some amazing set of teachers. I truly respect them. There's some amazing set of teachers out there. you can use any any of these teachers, find out the videos that they've sent, put out, use it to understand the concepts, and then apply it. That's all. It's as simple as that. At the end of the day, it's your life. It is your it's your brain that matters, not anything else. It doesn't matter where you're getting the knowledge from, as long as you're getting it. Grab it from wherever you can. Doesn't matter, even if it's from the kid. If he's able to explain a concept better than you did, then why not learn from him? There's nothing wrong in it. Because at the end of the day, nobody knows everything, but everyone knows something, right? Nobody knows everything, but everyone knows something. So learn from wherever you can. Doesn't matter whatever it is, whoever it is from. Doesn't matter the source. Get the information and then utilize it, right? So just don't give up. Be persistent, because 12th standard is even more important. It's going to be a little more harder. So you have to be mentally prepared to be, because 10th standard, it's very easy, right? It's all spoon fed to you. But 11th and 12th is not like that. It's going to be a little more harder. Engineering is even more harder. Or if you get into, medicine, that's even more harder. So it's basically going to be like that. So get used to it. That's all. All right. Anyways, is it? That's it. Just follow them. That's it. Just follow them. That's all I'm saying. All right. Just follow them. All right. Thank you, Chang. Thank you. Thanks a lot. All right. So it's all that matters is that at the end of the day, you need to get your knowledge. Doesn't matter where your knowledge is coming from, because your teacher who's correcting the paper doesn't care whether you watch this video or that video. All they care about is whether you wrote the answer or not. So focus on that. All right. So that's it, people. That's it, sir. Is PCB harder or PCM? If you see, it depends on what you want to choose next. Snowflake. It depends on what you want to choose next. So if you want to choose engineering, then math is a compulsory subject. So you need math, physics and chemistry. But if physics, if engineering is not what you want, and if you want to get into if you want to become a doctor, then PCB is a better choice, because you don't need math over there. So it depends on what you want to do. So what I would say is basically analyze yourself, understand yourself. Like, what is it that I am passionate about? You have to ask yourself this question. I'm pretty sure a lot of you guys, how many of you guys, okay, tell me one thing. When was the last time that you guys did talk to yourself? How many of you guys talk to yourself? Like, okay, tell me, when was the last time you talked to yourself? I do it all the time. I don't know about you guys. I do it all the time. I talk to myself, and it sounds crazy, but it is very cathartic in the sense it's very relaxing when you talk to yourself, because there's no one in the world, not even your parents, know you better than yourself, know what you want more than yourself, because you're you and nobody can replace you. So your thoughts matter, your answers do matter. So I don't know if you guys do that. Please do it. It's very cathartic. It's a good way to understand where you are right now and what you want. And please do that. All right, at least once in a while, please do that, and ask yourself, what is it that you want in life? If you want this is what you want, then please go with that. Nobody should be able to stop you there, because it's ultimately your life. And if you're not happy with what you choose, then you'll regret it for the rest of your life. All right. So whatever choice you make, it has to be yours. Then you'll be happy about it. If it's forced down your throat by someone else, it could be anyone, then you will not, you'll have a person to blame all the time. So if anything goes wrong, the first thing that you do is you point the finger at that person, because it's because of you that my life is like this. That is not something that I would suggest, right? Because regret is one of the worst feelings in life. So don't do that to yourself. Ask yourself, it's better to correct yourself right now than to feel sorry later. All right. Anyways, yeah, absolutely. Mirror or sitting and talking to yourself, whatever it is, talk. All right, just talk to yourself, because it's important. All right. What do you talk about, Vandana? What is the conversation like? Oh, you look so cute today, na? What are you wearing? Is that what you do? I can imagine Vandana talking to herself in the mirror, sitting and talking like, oh, you look so cute today. What dress do you want to wear? If that is what you're talking about, then it's pointless. I'm talking about life. All right. It's anyways. So that's it for today. I hope you enjoyed it. I'll catch you guys in the next session. Take care, guys. I really enjoyed the session today. It's been a long time. I always wanted to come live, but due to some reason I couldn't. So finally I'm live now, and it's been a long time since I've sent out any videos due to a lot of reasons. But nonetheless, I'm back now, and we'll try to be more regular. Syllabus is already done, so that's a good news. So we have only few subjective based questions to be done, which we'll be doing as we go ahead. So for all the 10th standard students, subscribe. All right, 9th standard also subscribe. 11th also, just subscribe. What will happen? What are you going to lose if you subscribe? Just subscribe. Alright, we have to reach 500k this year. That's right. Alright. So, anyways, guys, that's it for today. Catch you guys later. Bye bye. See you all. Enjoy yourself. Have a great evening. And adios. Konnichiwa. Arigato. Stay safe. Bye bye. Take care now. See you all. Peace. Bye.